Okay, so in this problem, we have Larry pushing a block and Mo pulling the block. So I've drawn the free body diagram. I have 150 newtons below the 45 degrees below the horizontal, and then Mo is pulling horizontally at 120 newtons. Of course, the block is in contact with the floor, so there is a normal force, and then the weight is pulling straight down. So you always start with your free body diagram, and if you need to, if you have something at an angle, go ahead and break it into components. So this is going to be Larry's x component and Larry's y component. So we could call this Lx and Ly. And because this angle here is 45 degrees, those two components are actually the same magnitude. We get 150 cosine 45, and here we'd have a negative vector 150 sine 45. Okay, after your free body diagram, next step is always the sum of the forces in the x equals max, and the sum of the forces in the y equals may. So in the x direction, we have Larry's x to the right, and we have Mo's 120 newtons to the right equals the mass of the block times the acceleration in the x direction, which we'll just call a because that's the only acceleration occurring in this problem. In the y direction, we're going to have the normal forces pointing up, so it's positive. We say minus L sub w minus the weight equals 0. Why is this 0? Because there's no motion. The box is not rising up off the floor and it's not sinking through the floor, so there's no acceleration in the y direction. So over here, we can take 150 times the cosine of 45. I have my calculator here. Cosine 45. So 106 point, let's do 106.1. So we have 106.1 plus 120 equals 200 times a. So we take 106.1, we add it to 120, divide by 200, so the acceleration is 1.13 meters per second squared. 1.13 meters per second squared. To find the normal force, we're going to come over here in the y direction. In this case, it's not equal to the weight because there's another horizontal force. If you think of it, Larry's actually pushing the block harder into the floor because he's pushing down on it. So we get the normal force equals Ly plus mg. So then we get N equals, well, Ly is the same as Lx, so it's going to be 106.1 plus 200 times 9.8 is 1,960. Okay, I don't know what I did there. 1,000. Okay, sorry. You can tell I'm still getting used to this. 1,960. So add those two numbers together and you would get the normal force.